Hello, everyone. A very warm welcome to your own Silicon Valley Tech Talks show, your go to place to learn about technology trends and innovations directly from the leaders. This is your host, Faisal Vatu from San Jose, California. ARM is one of the pioneer companies in the hardware space. They design energy efficient processor architectures, which are powering almost 99% of smartphones in the world and billions of devices across AI, automotive, and IoT. While ARM has dominated the mobile industry, now they have also been expanding into infrastructure space with the innovations and impact. We are fortunate to have Mohamed Awad as our guest today. Mohamed is Senior Vice President and General Manager of ARM's infrastructure line of business. Before ARM, Mohamed held leadership roles at companies like Broadcom, Lucent Technologies, and Nortel Networks. So without any further delay, let's go and talk to Mohammed and learn from his insights. Hello, Mohammed. Welcome to our show. How are you doing today?
I'm doing great. Thanks for having me.
Cool. So, Mohammed, in the recent talks, you have said that because of AI and energy constraints, we need to rethink data centers silicon up. Can you please elaborate a little bit more on that and how is ARM planning to work with OEMs and cloud partners to address that?
Yeah, sure. I mean, the sort of demand that AI is placing on the infrastructure has really been extraordinary. You see this every day with these new announcements about gigawatts and gigawatts worth of new capacity coming online. You think about the rate at which AI adoption has started to happen, whether that's with OpenAI or Gemini or any of these kind of massive platforms. And ultimately, what's happening is within the infrastructure, it's really struggling to keep up. It's struggling to keep up with the demand. It's struggling to keep up with the performance required. It's struggling to keep up with the power that is being consumed. Ultimately, that's leading the folks that are building out these data centers to really reevaluate all aspects of the system, look for optimization everywhere in the system. And this is not unlike any new technology trend where, the winners, the folks that are able to keep up, really reimagine everything that's possible. We've seen that in automotive with, the revolution of electric cars. We saw that with mobile phones. We see that over and over again. And in the data center, it's really no different. It really requires, those largest technology providers, whether it's AWS or Google or Microsoft or NVIDIA, Meta, they're all looking at all aspects of the system, starting with the silicon, all the way up through the system design, the rack level design, through the networking, the pod, and then the actual warehouse, and looking to optimize every ounce of energy and trying to squeeze every ounce of performance out of every ounce of energy. For our part, what ARM does is we enable those partners to go off and create and optimize their silicon around their workload, around that AI workload, around that data center. Very different than what used to happen, which was, they would pull off the shelf CPUs or off the shelf silicon, whatever was available, and try to use that to build up a data center around it. Now it's kind of flipped on its head where they're building that silicon specifically for the workload, specifically for the data center.
So, Mohammed, congratulations on ARM's appointment as a board member on OCP, Open Compute Project. Indeed, a signal on big bet on open collaboration. So, in your view, what are the biggest barriers in standardizing AI infrastructure across the industry?
Yeah, thank you. First of all, thanks for the congratulations. I mean, ARM has been a active participant in OCP since 2018, so for quite some time. And, we've been investing in infrastructure since even before that, 2011. It also happens to be the same year that OCP kicked off. So it's been a long road. It's not like we just showed up one day and started joining, in the technical collaboration. Standardization has consistently been a way and a force for good in the technology ecosystem, in that it allows for the allocation of resources to those aspects of the technology which are most differentiated. We see this in lots of different areas, and the infrastructure is no different, especially in today's data center, where again there's this kind of desire to try to keep up with this massive amount of demand within a constrained power environment. And so, we see our role within standards organizations like OCP really focused around bringing together lots of different aspects of the ecosystem, finding areas of commonality across them, looking for areas where, looking for areas to partner with the ecosystem around areas where there is a clear synergy in terms of what is trying to be accomplished, and then working with the ecosystem to develop technologies and products and interoperability between products, which allows for the amortization of cost across lots of different partners while allowing them to continue to invest and focus resources on those really highly differentiated aspects of the system. You know, in many ways, that's what ARM's always done. That's what our CPU architecture is about. That's what our CPU implementations are about. It's about taking that cost, amortizing across lots of different partners, and then allowing those partners to kind of focus their investment on the areas of real maximum differentiation.
Mohammed, ARM CPUs like Neoverse are powering custom AI platforms in hyperscaler data centers like AWS and Google. What are some of the other ways in which you are planning to help hyperscalers in their AI data center objectives? For example, some subsystem designs, or we also know that many of the hyperscalers are working on their own custom chip solution. Are you able to help them in those objectives in any ways?
Yeah. I mean, Neoverse is much more than a CPU. Neoverse is a complete compute platform. It includes things like our mesh interconnect. It includes things like all of the technology and IP that's required to kind of build an SoC. And now it also includes our ARM Total Design ecosystem, where we have an ecosystem of partners that include foundry partners like TSMC and Intel and Samsung. It includes ASIC design partners like Broadcom and Marvell and Socionext and others. It also includes our third-party IP vendors like Synopsys and Cadence and Ilion and these other companies who are all building technology in support of our Neoverse compute platforms. And so ultimately what that means for ecosystem partners like, AWS or Google or Microsoft or NVIDIA or Meta, who are looking to build these custom solutions, is that we've done a lot of the work to kind of bring all these technologies together. So when those customers come to us and come to the ecosystem, they can get right to the heart of what matters to them. If that means building out custom acceleration, they can go off and do it. They can come to our ecosystem, they can get a chiplet, or they can get some pre-integrated IP, and off they go. If that means building up the entire rack system, then that's fine. They can come to our ecosystem and get an SoC and start to put some of those components together. I think the point is that between ARM and the ecosystem, what we're really doing is providing multiple integration points along that spectrum so that our technology partners, those kind of large consumers of compute, whomever they are, can decide where they want to integrate for a particular product and really, accelerate time to market and really focus their investment.
So, Mohammed, in next few years, let's say next 5 years, what is the biggest disruption you are anticipating in AI infrastructure space?
Well, I think, the next few years are going to be quite astonishing, right? Like if you look at the sort of amount of capital committed to kind of massive build outs, if you look at the rate at which demand is happening, I think what you're going to see is this kind of ever increasing demand for performance per watt specifically, so that you can eke out as much performance from the available power as possible. I think you're going to see this kind of race for faster and faster time to market, and I think that the very nature and architecture of the systems is going to evolve at an incredibly rapid rate. I mean, we're seeing that already. And I think the next few years, I think that's only going to accelerate. We are really only at the start here. For all the talk about AI, for everything that's happened in the last couple of years, for the kind of transformation that the data center is going through, this is just the beginning. If you think about what AI is today, it's really about, some of these interactive systems where you can more easily interact with some of these computer interfaces, et cetera. But we're just beginning to tap the potential about what this means for healthcare and drug discovery. And, environmental challenges or solving some of the world's, largest problems. We're just really getting going on that. And I think, if anything, what you're going to see in the next few years is this kind of massive evolution of the adoption of the technology in ways that we really can't fathom today. While at the same time, data center, which is going to continue to struggle to keep up, quite candidly. And that's going to mean, looking for better and better efficiencies and faster adoption of new technologies.
Thank you so much for joining our show. I'm sure audience learned a lot from your insights.
Thank you so much, Faisal. Really appreciate it.